Okay, this second example is actually quite similar to the first set of questions that we just went over. So if the first one makes sense, like I don't think you have to watch this video, unless you just want more practice and check your answer. Alright, so the owner of pet store is trying to decide whether to discontinue selling specialty clothes for pets. She suspects that only 4% of the customer buys. So that's the probability of success, right? She might be able to replace the clothes with more interesting blah, 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 blah. 1. Assuming the pet store owner is correct in thinking that only 4% of her customers purchase specialty clothes for her, how many customers should she expect before someone buys? Again, like it's like until it's a geometric setting, right? So expected value for geometric setting is 1 over p, so we do 1 over 0.04, so that's 25. So she can expect 25 people. 2. What is the probability that she does not sell a garment until the 7th customer, right? So the 7th customer means that you had 6 failures and the 7th person was a success. So 7 failures, so the probability, probability of failure is 9, 6, right? And 6 of them. And then the one last one gets the 0.04. Ooh, let's do that on the calculator. 0.027, wait, I typed it wrong. 0.3, sorry, 13, okay, 1. What is the probability that exactly 3? So we know that this one, you can use binom PDF because of the wording exactly, and because it gives you n, which is 10. So you can plug it in 10, 0.04, and 3. Or you can write x equal 3 when x is the number of customers buying the specialty clothes. So you know that you need to define your variables all the time. So you should have done that in the in this question and onward, right? X is the number of customers who buy specialty clothes for this pet store. And this one can be found by doing combination first, and then you do 0.04 cube, 0.96, 7. Okay, so let's do that. I'm gonna just do binom PDF on my calculator because it's the easiest. 0.4 and then 3. So that's 0.00577. So my answer is 0.00577. And then we move on to the next one. What is the probability that at least 3 of the first 40, so 40 is my n, 3 is my x, so at least 3, right? So another way to write this is because you don't want to do x equal 3, x equal 4, x equal 5 and add them up. You want to do p, 1 minus, that's what I want to, 1 minus p x 2, right? Because you don't wanna include. So then it's 1 minus, you can do binom CDF. I don't know why my pen does that sometimes. 40, 0.04, and 2. Because this is n, this is p, this is x. Like I said, you wanna specify what you're doing. You don't want to just write binom CDF because they won't like that. So, and then we do 1 minus 0.7855, and that's 0.2145. That's not that many people. All right. The owner had 275 customers that day. Assuming that was a typical day for his store, I thought it was her store, maybe not. What would be the mean and standard deviation? So again, we need to check for the condition. So large number, large count. Oh, large count. That was the number. That was the word. Large count assumption, which is success and failure condition, which is NP is greater than 10, and NQ is greater than 10. And so N is 275, and P is 0.04, and that is 11. So 11 is definitely greater than 10, so check. And then we need to do 275 times 0.96, and you know that it's going to be, because it's a 275 minus that number, so it's 264, which is greater than 10. Check. Okay, independence assumption, which is met by, what's it called? 10% condition. Can you assume that he has more than 2,750 customers? Just overall? Well, I don't know. But what you can assume is that the customers will be, their purchase will be independent from each other. So you might want to approach it that way than using the 10% condition. Because I don't know when he says that day and it's a typical day. So I guess, like, if you look at a large picture, like maybe in like a year, then maybe 10% condition definitely like holds. But I think I'm just gonna say that we can safely assume that the purchases of each customer will be independent from each other. So then the independent assumption is met. Okay, I'm gonna approach it that way. So then the actual mean NP is 11, and standard deviation is square root of NPQ, and I think that's 3.25. Okay. Number 6, it says surprised by a high number of customers who purchased this specialty per clothing that day, the owner decided that again, it's changed to her instead of his. 4% estimate must have been too low. Okay, so we are going to use the normal approximation again, and because these conditions are met, that we can assume normal. We are assuming normal. So the mean 11, 3.25. Okay, that it must be too low. So what would be the number? So like now we are looking at this side of the number instead of this side, because the other problem, it was this number because we wanted to make sure that is it too high, right? And then now we are looking at, is it too low? So we are looking at this number right here. So I'm going to just assume 2 standard deviation away. So 2 times 3.25 is 6.5. So if this number is 17.5, so after 17.5, you're going over 2 standard deviation. So I can say that if you saw more than 18 clothing sales, then I can assume that 4% must have been too low, right? Because it would be actually more than 4% to make it true. All right, that's it. I don't know how else to review this unit. Unit review has been very difficult for me to make video for. So please let me know if this was helpful. Obviously, I don't want to do I don't want to make videos, especially if you guys are not watching it, and especially the College Board is doing a good job of putting the review videos. So make sure that if you watch the College Board review video and it's not making any sense, then please email me, contact me, whatever. I am going to do the week 5 quiz. I'm going to go over them as soon as everyone takes them. I think there are 3 more people who haven't. So make sure you do that. And other previous, I think there's one person who haven't taken the week 3 and week 4. And I don't like grading them until I have everyone's. And so please, 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 so that I can grade and then I can make videos. And I want to grade them first before I make the video so that I can go over the points that you guys were making like a common mistake, right? So please help me out by doing your part, and I will try to do my part as much as possible. I am going to listen to the webinar that they have for the 29th or so, because like I'm in the time zone that I could actually watch both of them because there are 2 sections quite easily. So I'm going to do that for you guys and then take notes in case you guys miss that webinar. So don't worry about if you miss it, but obviously it is great that if you can watch it for yourself and take notes and all that. So yeah, let me know how this video was, and I couldn't make it any shorter just because this is an entire unit and it's a quite important unit for you guys. So I will see you guys later.